Manufacturing helicopters involves a complex process that requires advanced engineering, precise manufacturing techniques, and stringent quality control measures. Here's an overview of how different types of helicopters are manufactured, focusing on the key stages involved. 1. Design and development. First, conceptual design. Requirements gathering. Define the helicopter's purpose, for example, military, medical, or commercial. Preliminary design. Create basic designs and outlines focusing on aerodynamics, weight, and materials. Next, detailed design. CAD modeling. Use computer-aided design software to create detailed three-dimensional models. Simulations. Perform aerodynamic and structural simulations to test designs. Prototype development. Build scale models or full-size prototypes for initial testing. 2. Material selection and procurement. Materials. Select high-strength, lightweight materials like titanium, aluminum, and composite materials for various parts. Supplier coordination. Work with suppliers to procure high-quality raw materials and components. 3. Manufacturing processes. First, airframe construction, metal cutting and shaping. Use CNC machines to cut and shape metal parts. Composite layup. For composite materials, layers of carbon fiber or fiberglass are laid up in molds and cured in autoclaves. Welding and assembly. Weld and assemble metal parts to form the airframe structure. Next, rotor system manufacturing. Main and tail rotors. Manufacture rotor blades using composite materials for lightweight and strength. Rotor hub, machining of rotor hubs which connect blades to the main rotor shaft. Dynamic balancing. Ensure rotor blades and hubs are dynamically balanced for smooth operation. Finally, power plant integration. Engine selection. Choose appropriate engines like turboshaft for most modern helicopters. Mounting and alignment. Precision mounting of engines to the airframe, ensuring proper alignment with drive systems. Transmission system. Manufacture and install the transmission system, which transfers power from the engine to the rotors. Now, let's move on to avionics and electrical systems. First up, wiring and cabling. This involves installing electrical wiring throughout the helicopter, ensuring that every component is connected and functioning properly. Next, we have avionics. Here, we install and test avionics systems, which include navigation, communication, and control systems. These are crucial for the helicopter's operation. Lastly, we focus on sensors and instruments. This step involves installing sensors and instruments that provide vital flight data and control, making sure everything is ready for a safe and efficient flight. Alright, so let's move on to the interior and final assembly. First, we install seats, controls, and interior panels. Then we integrate all sub-assemblies, which include the airframe, rotor systems, engines, avionics, and interior. Finally, we perform extensive quality checks at each stage to ensure all parts meet specifications. Next up is testing and certification. We start with ground testing, where we conduct static tests to check structural integrity and system functionality. Following that, we perform a series of flight tests to ensure performance, safety, and reliability. And of course, we obtain the necessary certifications from aviation authorities like the FAA and EASA. Now let's talk about delivery and support. Once the helicopter passes all tests and certifications, it is delivered to the customer. But it doesn't end there. We provide ongoing maintenance, spare parts, and support services to ensure the helicopter remains in top condition. Finally, let's discuss the differences in manufacturing various types of helicopters. First, we have light helicopters. These have simpler construction and fewer components. The focus is on cost-effective materials and production techniques. They are often used for private or commercial purposes like news reporting or traffic monitoring. Next are medium helicopters. These have more complex avionics and power plants. They are used for search and rescue, medical evacuation, and corporate transport. They require robust structures for carrying heavier loads. Then we have heavy helicopters. These feature high-capacity engines and advanced avionics. They are used for military transport, large cargo transport, and firefighting. The focus here is on durability, payload capacity, and advanced systems for mission-specific requirements. Lastly, there are military helicopters. These have specialized designs for combat, reconnaissance, and transport. They use stealth technologies, advanced weapon systems, and reinforced structures. They have stringent requirements for survivability and performance in combat scenarios. Each type of helicopter has unique design and manufacturing requirements based on its intended use, which influences the materials, technologies, and processes involved in its production.